2-3, solving multi-step equations. So our objective for this section is to solve multi-step equations in one variable. Okay, so we've looked at solving equations with one step. We've looked at solving equation with 2 steps. Now this is going to be more. Okay, so to solve multi-step equations, you first form a series of simpler equivalent equations. To do this, use the properties of equality, inverse operations, and the properties of real numbers. Use the properties until you isolate the variable. So our objective for solving equations is always the same, is I want to get a variable by itself equal to a number. Okay, so let's look at the first problem that focuses on combining like terms. So my goal for each step when I'm simplifying an expression, solving an equation, is to make it simpler. Okay, so the first thing I see is I see a 5m there and a 2m there. Well, we'll look at equations that have variables on both sides. That's a little bit different. But when we have 2 variables and they're on the same side and they're like terms, that's an m, that's an m, all we have to do is put them together. So we can take the 5m, the 2m, and if we really wanted to, we could rewrite this as 5m plus 2m minus 23 using the commutative property. We will combine the like terms of the 5m plus the 2m to give me 7m minus 23. And now this should kind of look like equations that we dealt with in the last section. Okay, so the next thing we're going to do is we're going to add the 23 to both sides. 23. Okay, remember our goal is to get the variable by itself. So after we combine the like terms, we're going to be doing our inverse operations, or our inverse operations, we're going to be doing them reverse from the order of operations. So add 23 to both sides, and we get 28 is equal to 7m. Divide out the 7 because it's 7 times m, and we get that 4 is equal to m. Now, of course, if I wanted to, I could always plug in the 4 for m times 4 and see, does this actually work? Okay, and then 20 minus 23 plus 8 is 5. So this does work, and I don't have to check it every time, but it's nice to know that I'm doing things the right way. All right, let's try some got it problems. Okay, so what do I notice? I notice I notice that the 11 and the 6 are both like terms. So I take the 11 minus the 6, and I get 5m minus 8 is equal to 22. Add the 8 to both sides. 5m is equal to 30. Divide both sides by 5. So m is equal to 6. For part B, same thing. I see we have a negative 2y and a positive 5y. When I add those together, I get a positive 3y plus 5 is equal to 14. Subtract the 5 from both sides. We get 3y is equal to 9. Divide by 3, and we get y is equal to 3. Okay? So when you see 2 variables, if they're on the same size, put them together. Let's look at a word problem. Okay? So, Martha takes her niece and nephew to a concert. She buys t-shirts and bumper stickers for them. The bumper stickers cost $1 each. Martha's niece wants 1 shirt and 4 bumper stickers. And her nephew wants 2 shirts but no bumper stickers. If Martha's total is $67, what's the cost of 1 shirt? Okay, so let's break this down. What am I looking for? That's my variable. How much does a shirt cost? Okay, so we want S to equal the cost of a shirt. Okay, so Let's look at the niece, what she wants. Martha's niece wants one shirt, four bumper stickers. Okay, well, a bumper sticker costs $1, so she wants the price of the shirt plus $4 because the bumper stickers cost $4. The nephew wants two shirts, so that's plus 2 times S. And when we add them all up, her total was $67. Okay, so we broke down the problem and figured out an equation. Now all we have to do is solve it. So we have an S, we have a 2S, put them together. That's a 3S plus 4 is equal to 67. Subtract 4 from both sides, and we get that 3S is equal to 63. Divide out the 3, and we get that the shirt is equal to $21. Okay? Word problems are not worse than our regular problems, right? Just break them down, make the equation. That's the hardest part, make the equation. Let's look at another one in our got it problem. Okay? Noah and Kate are shopping for new guitar strings in the music store. Noah buys 2 packs of strings. Kate buys 2 packs of strings and a music book. The book costs $16. Their total is 72. So again, we're looking for my variable. S is going to be price of the strings. Okay. So we have that Noah buys 2 packs of strings. Kate buys 2 packs of strings plus 2 packs of strings and a music book, which is $16. And that's all going to be equal to 72. Okay? And so once we break it down, once we make the equation, we combine the like terms. 4s plus 16 is equal to 72. And then I can solve this the same way that I've solved all my other problems. Subtract 16 from both sides. 4s is going to be equal to 56. Divide by 4, and I get that my pack of strings is $14. Okay. Next, solving an equation using the distributive property. Okay. So there's a couple ways I can look at this, and I'll look at the second way next. But when we have this situation right here, where we have this -8 out in front, one way I can solve this is to distribute. So I can take this -8 and multiply it to both of these. This gives me -16x. -8 times a -1 is a +8 equals 36. And now I have a simple two-step equation that I can solve. Subtract 8 from both sides. Simplify. We have -16x. Bring down the equal sign. 36 plus a -8 is going to be a +28. Divide both sides by -16. Uh-oh. We have a -28 over 16, which doesn't go in evenly. That's okay. We do have to simplify, though. So 28 and 16 are both divisible by 4. So 28, so we can factor out the 28, factor out the 4 and cancel. It's going to leave us -7 over 4. It's okay to get a fraction. Okay, still is the number that solves this particular equation. Okay, our got it problem. So let's do this one first the same way. Let's distribute. So that's 18 is equal to 6x minus 18. Add 18 to both sides. And we get 36 is equal to 6x. Divide by 6, and we get that 6 is equal to x. Now, part B says, can you solve the equation in part A by using the division property of equality instead of the distributive property? And I can. Let me rewrite it first. 18 is equal to 3 times 2x minus 6. Now, another way to solve these problems instead of distributing is to notice that my 18 right here is divisible by 3, and this is multiplication. So I can, as my first step, divide both sides by 3. That would turn into 6 is equal to, these two now cancel out, 2x minus 6. Then, of course, I could add 6 to both sides, divide by 2, divide by 2, and we get that 6 is equal to x. Okay? Same answer, just different method. This method works well if this term happens to be divisible by that term. If it's not, it's probably better to use the distributive property. And in fact, in this first problem, I could have tried to divide by -8, but 36 is not divisible by 8, so I don't think that necessarily makes this problem any easier. I think it makes it a little bit harder. Okay? So use the division property if the thing on the other side is actually divisible by what you want to distribute. Okay? We can use different methods to solve equations that contain fractions. So we're going to look at two different methods to solve this fraction problem. The first way we can do it is to change the equation on the left side to something with a common denominator. So let's do that. So let's start with 3x over 4 minus x over 3 is equal to 10. I have to ask myself, what is the common denominator between 3 and 4? Well, it's 12. Okay? And in order to change 3 over 4 to something over 12, I have to multiply the bottom by 3, which means I have to multiply the top by 3. To turn x over 3 into something over 12, I have to multiply the 3 by 4, which means I multiply the top by 4, excuse me. Okay? Now that there's a common denominator, I can put the left side together. So 9 minus 4 gives me 5x over 12 is equal to 10. And hopefully you remember that in order to clear a fraction, I multiply by the reciprocal. Okay, so the 12s cancel, the 5s cancel, and we're left with x is equal to 10 times 12 is 120, divided by 5 is 24. The better way to do this, though, when I multiply these two numbers together, especially if we're not using a calculator, is to cancel this 5 with one of these to make that a 2. And now all I have to do is multiply 2 times 12, which is 24. Let's look at the next method. The next method is to clear the fractions from the equation. So let me write this problem over again. It was 3x over 4 minus x over 3 is equal to 10. Okay? So now what I can do is I can multiply everything by the common denominator, which in this case is still 12. Okay, so when I multiply everything by 12, I'm going to distribute this 12 to each term, all three, the left side and the right side. Because if I want to multiply the left side by 12, I have to multiply the right side by 12 to keep the equation balanced. Now, when I multiply 12 times 3x over 4, the 4 and the 12 can reduce to just a 3. Okay, so that would be, or I can take 12 times 3, divide the answer by 4 to give me 9x minus 12 times x divided by 3 is 4x is equal to 120. Don't forget to multiply the right side by 120. That's what a lot of people do. 9 minus 4 gives me 5x is equal to 120. Divide out the 5 to give me x is equal to, same thing, 24. Okay? Personally, I like this method a little bit better, clearing the fractions. I think it makes the problem a little bit easier. You don't have to mess around with common denominators. I think usually that works out. Okay? So let's try these two Gotta problems, and let's use the first method on the first one, the second method on the second one. So the first method was to find the common denominator, which is going to be 20. So that turns into 8b over 20 plus 15b over 20 is equal to 3. Hopefully I didn't make a mistake there. 8 plus 15 is equal to 20, whoops, 23b over 20 is equal to 3. So now we're going to multiply both sides by 20 over 23. Okay, so now we have b is equal to 60 over 23. Is that correct? Yeah, good. Okay, so next, let's clear the fractions in the second one. Well, I can take the 3 and multiply it by 3 to get 9. That's good, but that's not the common denominator of all of them. The least common denominator of 6, 9, and 3 is going to be 18. Okay, because 6 and 9, 6 does not go into 9. Okay, so what I want to do equals 5 over 6 minus m over 3. I want to take this whole thing and multiply it by 18. 18 times 1 over 9 gives me a 2. 18 times 5 divided by 6. 18 divided by 6 gives me a 3 times 5 is 15. And then minus 6m. Subtract 15 from both sides. That's negative 13 equals negative 6m. Divide out the negative 6, and negative over a positive gives me a negative, or a positive. Negative over negative gives me a positive. So that's 13 over 6 is equal to m. Make sure I can't reduce, and I can't. So both of these were a little bit harder in that they gave you fractional answers, but not too bad. Okay. And our last example shows us that we can clear the decimals from an equation by multiplying by a power of 10. First, find the greatest number of digits to the right of any decimal point, then multiply 10 raised to that power. So what does that mean? It means if I have this equation, I could, if I had a calculator handy, I could subtract 3.5 from both sides and then just divide out the negative 0.02. Okay, but I also could say, well, there's stuff here that is that has two decimal points. So I should raise everything by 10 to the second power, which is 100. So if I take this whole equation and multiply it by 100, I will clear all the decimals, which gives me 350 minus 2x equals 125. So now I will subtract 350 from both sides, which gives me negative 2x is equal to negative 226. Divide both sides by negative 2, and we get that x is equal to positive 113. Okay? Useful if you want to try to do a problem like this without a calculator, which you will have to do on some of your standardized tests. So again, I look to see how many decimal points are there. Well, this one has 3 numbers behind the decimal point, so my best thing to do is to multiply everything by 1,000. So I'm going to take 0.5x minus 2.325 equals 3.95, and I'm going to multiply this whole equation by 1,000. Unfortunately, this is not going to make the equation too much easier to solve by hand. We're going to get 500x minus 2325 is equal to 3950. When I multiply things by 1,000, I move the decimal point 3 times to the right. Add 2325 to both sides, and I will get 500x is equal to 2325, 6275. Unfortunately, not the prettiest problem. And we get x is equal to 6275 over 500. We will have to reduce this, so I'll have to divide out common factors, and eventually you get this down to 251 over 20. Okay? So, our lesson check. Solve each equation, check your answer. My first step here would be to combine the 7p and the 8p, add 12, then divide by 15. Then we're going to either find a common factor or multiply both sides by 14. For this one right here, I could choose to either distribute or divide out the -2, either way. And for number 4, I can choose to solve this with a calculator or to multiply the whole equation by 10, because there's one decimal behind the decimal point. Set up the word problem. There's a 12-foot fence on one side of a rectangular garden. The gardener has 4 feet of fencing to enclose the other 3 sides. What's the length of the longer dimension? So I know that it's going to be 44 is going to equal to 2x and then 12, right? Because if I have a rectangle and I know that this side is 12, this side has to be 12. These two sides are x. Longer dimension, so I wrote this backwards. Okay, but we already have this fence right there. So 2x plus another 12 feet, because these two sides have to be the same, is going to be equal to 44. And that's my setup. Subtract 12, divide by 2, gives me 16. Okay, so this side is 16. And again, I just drew the picture a little backwards. How would I solve this? Again, multiply everything by 100, or we can use a calculator. Divide out the 7 first, or distribute the 7. And here, common denominator with these two, or I would think it's easier to multiply well, what could we multiply by? 18. If we multiply this side by 2, unfortunately that's not the least common denominator of 9 and 18, because if I multiply this side by 2, I have to multiply this side by 2 as well. Just got to figure out the least common denominator of 9 and 18 to figure out how to get that. Okay. Ben solves an equation, -24 is equal to 5g plus 3 by first dividing each side by 5. Amelia solves the equation by using the distributive property. Whose method do you prefer? Because these two are not divisible, I prefer Amelia's method. Okay. If they were divisible, if this was a 25, then Ben's method might be a little faster. Okay. So that was 2-3, solving multi-step equations.